Hey everybody. We're going to take another look at some more graphs or statistics today, but today we're going to focus more on quantitative graphs, whereas last class we focused more on categorical graphs. So we're going to be working more with graphs that involve numbers today. So we can go ahead and get going on that. Let me share my screen with you all. So on Canvas here, if you've got these notes, you can, if you hit that full screen right there and you want to follow along, that's fine. If you want to print them out, that is also fine. It is whatever works better for you. And so we're going to be working on displaying more distribution of the data with graphs. And the first thing that I want to do is I really want to go over these three things right here: center, shape, and spread. We talked about them last class, but I want to go a little bit more in depth. For center of data, that is specifically talking about the mean or the median. That is more like, where is the center of this data at? And you can measure those by either doing the median of the data, or you can measure those by doing the mean. The shape here, we're going to get to in just a second, but that just refers to what pattern does your graph's data follow. And again, the spread is the range. So just what's the lowest value it goes to what's the highest value that it goes to. And again, for outliers, we're still looking for unusually large and unusually small values relative to the rest of the data set. So if something on a graph, you're like, wow, that's kind of far away. For right now in statistics, that's just how we're going to define an outlier. Now, with those shapes, there's three kinds of shapes that you can have for a shape of a distribution. So you can have a symmetric one, which is you can just cut it right down the middle here, and you're going to have two even halves. You have what's called a skew to the right. So the majority of the data is on the left-hand side here, as opposed to the right-hand side. It's pushed, it looks like it's getting pushed over from the right. And then you have what's called skewed to the left, which is just the opposite. It looks like you put a hand in there and you push this graph from the left-hand side. And so when we're talking about data, we're going to be using these three words when we're talking about the way that graphs look. So you can use the shape, you can use the spread, and you can use the center. Now, expanding on those outliers just a little bit, there's three reasons you all could see an outlier in a data set. So the first one is a natural occurrence. For whatever reason, sometimes people are just a outlier one way or another. You think of like NBA players with height. Most of those guys are natural outliers for height in the positive direction. I think they have guys going up to 7'6" there, which are obviously not very common for people to see. You could also have mistakes in data entry. So people largely, when they're recording data, will use a computer. Mistakes happen. So if you're like, man, this looks way off, is what went on here? It could just be a simple human mistake. People make mistakes and it happens. The last thing is that it could be the wrong population. So it could be that the people that you are conducting a study on or conducting an experiment on is probably not the ideal people to do that on. So if you're wanting to see, like, do shoes performance of a runner, you're probably going to want to test people who consider themselves runners and who run frequently, as opposed to people who don't run quite as frequently. Or if you're wanting to test, like, let's see, if you're measuring video game ability, you're not going to go run an experiment on someone who hasn't played video games. I was trying to think of how to word that, so I apologize if that came off as choppy. So the two graphs that we're going to look at today for quantitative graphs. So last class we did circle graphs, we did dot plots, we did, I'm trying to think, do we do bar graphs? I don't know, someone will let me know. So quantitative graphs, the two that we're going to look at today, we have what's called a stem and leaf plot, and we have what's called a histogram. You've probably seen those in some sort of fashion, but we're going to go over both today just to make sure that we're good to go. So we're going to do stem plots first. So it's split up to where it's a stem and it's a leaf. And the biggest thing is we're going to go lowest to highest on our stem, and we're going to go lowest to highest on our leaves. So the stem is going to be everything but the last digit, and the leaf is just the last digit in whatever number that we're dealing with here. And so let's look at an example here real quick of that. So what I'm going to do is I'm going to make a stem and leaf plot. This table right here is the percent of residents age 65 and over in the states in 2007. So what I'm going to do is I'm going to create a stem and leaf plot for the left-hand side of this, and then I'm going to have you all submit a stem and leaf plot for the right-hand side of this, and then that way we'll be good to go. I'll know that you can do it. But when I'm talking about stems and leaves, the stem is all of the numbers right here. It's the biggest part of the number, and whatever the last digit, we consider that the leaf of this thing, and we list those out in this table right here. Now, whenever you read this, like 13 and then dash of 5, that would just be the equivalent of 13.5. So whenever I'm creating this table right here, to do this, I'd say 13.5, okay, space, or you can use a comma, it does not matter. So then you've got to record this for each one, and it makes it a little bit easier to see what's going on. So what I'm going to do is I'm going to do the left-hand side. I'm going to go from Alabama to Missouri. We're going to list the states with the oldest people, and we'll go from there. So Arizona is 12.9. Arkansas is 14. If you want to fast forward through this part of the video until I'm done with it and just follow along, that is also fine. You don't have to sit here and watch me punch numbers in the entire time if you do not want to. So let's see, 13.5 for Connecticut, 13.6 for Delaware, Florida with a whopping 17%. They've got a lot of old people in Florida, apparently. 9.9. 14.3 for Hawaii. Old people really love those warm states, apparently. Let's see, Idaho is 11.7, 12.1. And the important thing here, guys, to make sure that your stems are in order as well. Let's see, so then Indiana is 12.5. We've got Iowa, which is 14.7. We've got Kansas, which is just 13.0. And you don't have to do this on a computer. You're more than welcome to do this on a piece of paper. But the thing that you need to make sure it has a title. You need to make sure it has a legend. So we just did that. Let's do Maine now, 14.8, okay. Maryland is 11.8. Massachusetts is a 3, 13.3. Michigan is 12.7. Let's see, Minnesota is 12.2, the same amount as another state. Let's see, Mississippi is 12.5. And then Missouri with 13.4. And so you can kind of start making guesses on the shape of this, on the spread of this, and the outliers and whatnot, as well as, shape, center, and spread. So as you all can see, my stem plot, it does look like it's pretty symmetrical if you're going to draw a line with that. But what I want you all to do now, before you all can get to that homework worksheet, you're going to have to make a stem plot and a histogram here. So the stem plot is just going to be with the right-hand one. So you're going to go from Montana to Wyoming. So going back to those notes now, now that we've looked at a stem plot, the last thing that we're going to look at is histograms. Now, for histograms, Again, these are used for quantitative data. They're a bar graph that has no spaces between the bars. Now, the biggest thing with you all with the histogram is you all have to decide how far each one is. So whenever you're making your axis, like if you're going to go by fives, it has to go by fives the entire time. And then the other thing, histograms are like a trickier bar graph, is that the left-hand value here is the most included. The right one is not. So like if you had 0 to 5, it would not be included there. Like 0 is included, 5 is not. 5 to 10, 5 is included, 10 is not. 10 to 15, 10 is included, 15 is not. So I'm going to go over an example of a histogram with you all real quick. And again, we're going to do some left-hand, right-hand stuff. So the data I'm going to be using is going to be the left-hand side from A&W to my personal favorite, Dr. Pepper. And let's see here. The lowest, I'm looking at this, it looks like we go from 15 all the way to 47. So what I'm going to do is I'm going to make a graph here, and I'm going to have it be for this left-hand side. I want you all to make it for the right-hand side, and we can go from there. So let me stop sharing my screen here so that we can get to the points. All right. So I'm going to go from, so this is obviously 0. So we're going to go from 0 to 10 to 20 to 30 to 40 to 50. And the onus is on you. You have to decide what your scaling wants to be. If you wanted to go by 5s, you could. If you wanted to go by 20s, you could, or by 30s, you could. You kind of just have to think about what it is that you're measuring here. Since we're doing caffeine, I wanted to do 10s. So the bottom one here is going to be our number of occurrences. And then, or not number of occurrences, excuse me. Mr. Price is going to make mistakes too. So this is going to be caffeine, which is in milligrams. And this is going to be occurrences up here. So for this, we're going to say, all right, how many are between 0 and 10? So at this point, I'm looking at the chart I've posted, and there are none. So then I'm going to count the ones that are between 0 or 10 and 20. So it looks like the 15 and a 15. So we've got 1, 2. So I'm just going to draw a bar going up to 2. And shade that. So then I need to count from 20 to 30. This is probably where most of the things are going to occur. So let me count real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I certainly don't have enough room here. We're going to make an adjustment. We're going to make that 2, 4, 6, 8, 10, 12, 14. So then this next one right here is going to go up to 13. So we're going to call that 14 up there. And then let's see, from 30 to 40, what are the really high caffeine ones here? We've got Diet Coke, we've got 2, 3. We've got 3 that are in between those. And we're going to draw that graph right there. And then the last one that is Diet Sunkist, which is apparently a wildly caffeinated, oh no, that's Diet Sundrop. I can't be slandering Sunkist out here. And then the last thing I guess that this needs is a title, right? So caffeine content for an 8-ounce serving. So let's see, we'll put that here, caffeine content for 8-ounce soda. So what I want for you all to do today is to make sure that you all create a stem and leaf plot for the right-hand side of the state data, create a histogram for the right-hand side of the soda data, And then I've got 3 problems for homework that I want you all to do. And we will go from there. Thanks a lot, y'all. See you.